Decay of long-lived radioisotopes is the primary method for dating materials. The mathematical expression relating decay to geological time is where T is the age of the material, D is the current amount of the daughter product, and P is the current amount of the parent isotope. Ln stands for natural logarithm, and T1/2 is the half-life. This is how one uses radioisotopes to estimate the age of a substance. Stable isotopes provide proxy measurements for climatic parameters such as temperature and rainfall. Most chemical reactions proceed faster with one isotope than another. In particular, the photosynthetic reaction that incorporates carbon dioxide into organic carbon compounds proceeds faster with the light carbon-12 carbon dioxide and slower with the heavy form carbon-13 carbon dioxide. Photosynthesis is said to discriminate against the heavy form. When carbon dioxide is plentiful, photosynthetic organisms discriminate strongly against carbon dioxide that has the heavy carbon-13, and therefore their carbohydrates and organic carbon become strongly enriched with the lighter carbon-12. When carbon dioxide is limiting, photosynthetic organisms use whatever carbon dioxide is available, and their organic carbon becomes less enriched than the light carbon-12. Consequently, the ratio of carbon-13 to carbon-12, called delta 13C, in organic carbon found in rock sediments derived from these organisms, varies inversely with carbon dioxide concentration in the atmosphere. As aquatic organisms photosynthesize and preferentially assimilate the light form of carbon dioxide, carbon-12, the carbon dioxide remaining in the surrounding water becomes depleted of this light form. That is, the water becomes enriched with the heavy carbon dioxide. Thus, the ratio of carbon-13 to carbon-12, the delta 13C, in the carbonate rock that precipitates from this water, increases with photosynthetic activity. Isotopes of a single element also differ in their rate at which they change phase from a solid to a liquid or a liquid to a gas. A molecule in the gas phase moves randomly and at higher speeds than the same molecule in the liquid phase. The liquid phase, in turn, moves more randomly and at higher speeds than the same molecule in the solid phase. Heavier isotopes are less adept than the lighter ones in moving at rapid movements. At a given temperature, when molecules have a certain amount of kinetic energy, molecules with a heavy isotope are less likely to evaporate, change phases from liquid to a gas, or melt, change phases from a solid to a liquid, and more likely to condense, change phases from gas to liquid, or freeze, change phases from liquid to solid. Higher temperatures stimulates the motions of all molecules, and a greater percentage of those with heavy isotopes cross the threshold to change phases.